Hello student, my name is Shashank Shekhar. So let us start with this exercise of NCERT exercise of structure of atom. So the first question says that calculate the number of electron which will together weigh 1 gram. What we have to calculate? We have to calculate the number of electron which will together weigh 1 gram. Second question, calculate the mass and charge on 1 mole of electron. So first let us do the first question. What does it say? That we have to calculate the number of electron which will together weigh 1 gram. So for that we have to look upon the mole concept. So what does mole concept says? So mole concept says that 1 mole of electron, we have to calculate the number of electron in 1 gram. So we know that the mass of an electron, mass of 1 electron is 9.1 into 10 to the power minus 31 kg. So this is the mass of 1 electron. We know this. Clear? 9.108 into 10 to the power minus 28. Sorry. 9.20 into 10 to the power minus 28. So this is the mass of 1 electron in kgs. Now, if I want to convert it into gram, so it will be 9.1 into 10 to the power minus 31 multiplied by 10 to the power 3. That much gram, that would give us 9.31 into 10 to the power minus 28. 28, 3, 21, yeah. So this is the mass of 1 electron. Now in 1 gram, how many electrons will be there? So this is just a simple unitary method. So if one electron weighs this much, then 1 gram will be equals to 1 by 9.1 into 10 to the power minus 28 gram. When you will calculate this, you will get your number of electrons. Clear? Okay. What does next question says? We have to calculate the mass and charge on 1 mole of electron. Mass and charge on 1 mole of electron. So charge on 1 electron, charge on 1 electron is how much? 1.6 into 10 to the power minus 19. 1.6 into 10 to the power minus 19 coulomb. This is the charge on 1 electron. So charge on Na electron, that is 6.022 into 10 to the power 23 or 1 mole of electron. So charge on 1 mole of electron will be. So how you will think it? So if you go to a shop and the shopkeeper says that the price of 1 chocolate is 2 rupees. Now if you have to say buy 2 chocolates, then how many rupees you have to give to the shopkeeper? So that would be simply the multiplication of 2 multiplied by 2. So that same concept will be applied here. So if charge on 1 electron is this much, then charge on 1 mole of electron is how much? That will be 1.6 into 10 to the power minus 19. And you know what is the count of electron in 1 mole? That would be equals to Na. And Na is 6.022 into 10 to the power 23 mole. Or in this case, electrons. So this is the Avogadro constant. So we'll simply multiply with this value to get our charge on 1 mole of electron. Now, if you have to calculate the mass on 1 mole of electron, mass on 1 mole of electron, how you will calculate? So we have seen that the mass of 1 electron is 9.1 into 10 to the power minus 31. So this is the mass of 1 electron. So 1 mole will be again multiplied by 6.022 into 10 to the power 23. So that would give us 9.1 into 10 to the power minus 31 into 6.022 into 10 to the power minus 10 to the power 23. So the multiplication product will be your answer. So the same thing is done here. So the mass of 1 electron is this much. So 1 gram would contain 1 by 1.9108 into 10 to the power minus 28. So that is this much number of electrons are there in 1 gram. Next is mass of 1 mole of electron. We have to simply multiply the mass of 1 electron with 1 mole. So here it has been found in grams. So if the question says to give the unit, say the question has asked to give you the answer in gram or kg, then you will specify it. If not, you can keep it in gram on kg or kg. Okay, clear? Now charge on 1 mole of electron will be how much? So again, charge on 1 electron multiplied by 1 mole, that is 6.022 into 10 to the power 23. That would give us 9.63 into 10 to the power 4 coulomb. Next, find the total number of electron present in 1 mole. What you have to find? We will do the question. We will do these questions one by one. So first question, let us see. You have to calculate the number of electrons in 1 mole of methane. You have to calculate the number of electrons in 1 mole of methane. So for that, let us first calculate the number of electron in 1 methane. So how you will calculate it? So for that, you will simply add the atomic numbers. We know this, that our say number of electrons is equals to the atomic number for neutral species. So since this is carbon and we have to find the number of electrons, so what we will do? Number of electrons in 1 molecule of CH4. How you will find it? So 1 carbon contains how many electrons? 6 electrons. Clear? Hydrogen, helium, lithium, beryllium, boron, carbon, 6 electrons. So 1 carbon, so multiplied by 1, plus 4 hydrogens. So each hydrogen will contain 1 electron. That would give us a total of 6 plus 4. Means there are 10 electrons per methane molecule. Now you have to calculate the number of electrons in 1 mole of methane. So number of electrons in 1 mole of methane would be how much? So 1 contains 10 electrons. So 1 mole will contain 10 multiplied by 6.022 into 10 to the power 23 electrons. So this much electrons will be present. So that would give us 6.022 into 10 to the power 24 electrons. Got it? What does the next question say? So this will be the solution. So 1 mole of methane will contain 10 electrons. Therefore, where 6 will be from carbon, 4 will be from hydrogen. Therefore, 1 mole will contain 10 into this much. Next, find the total number and total mass of neutrons. What we have to calculate? Total number and total mass of electron in 7 mg of 14 carbon. You have to find this. So again, let me clarify the question for you. So it has been asked, you have to calculate the number of neutrons. And you have to calculate the mass of neutrons which is present in 7 mg of 14C, and here also in 7 mg of 14C. So this you have to find. Got it? Now what is the meaning of 14C here? So therefore it means that we have a atomic mass of 14. Atomic mass 14. And we know that atomic number of carbon is how much? Of carbon is equals to how much? 6. So therefore number of neutrons in 1 carbon atom will be atomic mass minus atomic number. That would give us 8 neutrons. So this much neutrons are present in one atom of 14C carbon. Clear? Now this much neutrons is present in one atom of 14C carbon. Now you have to calculate in 7 mg how much neutrons will be present and what will be their mass. So first of all, let us try to find out the number of 14C carbon in 7 mg. So we will find this first of all. So how we will find it? For that, we know that here the atomic mass is given as 14 gram. Okay, so that means what will the number of atoms? First, we have to find the number of atoms in 7 milligrams. So we know that in 14 gram there will be 6.022 into 10 to the power 23 10 to the power 23 14C carbon atoms. Is this clear? You know this one. So this is we know that the what is the atomic mass of any substance defined. It is that amount which will contain this much amount of entity. So from that we have written. So since we are taking 14C carbon, not the 12C carbon, so therefore here 14C gram of carbon will contain this much number of carbon atoms. Now we have to calculate it for 7 milligram. So first we will calculate it for 1 gram. So that would be 6.022 into 10 to the power 23 by 14. Is this clear? Yeah. So this much carbon atoms. Now if we calculate it for 1 milligram, so millicentidecigram. So for 10 to the power minus 3. So for 10 to the power minus 3 grams, we have converted into milligrams. This much is 6.022 into 10 to the power 23, 14C carbon atoms. Now again applying the unitary method, in 1 milligram it will be again, this will be divided by 6.022 into 10 to the power 23 by 14 by 10 to the power minus 3, 14C carbon atoms. Now in 7 milligram, how much will be present? In 7 milligram, we have to just simply multiply it. 7 milligram of 14C will contain how much carbon? 6.022 into 10 to the power 23 into 7, and the downwards was how much? 14 multiplied by 10 to the power minus 3, 14C carbon atoms. So in 7 milligram, we have this much number of 14C carbon atom. And we know that one 14C carbon atom has how much neutrons? 8 neutrons. So this amount will contain 8 into 6.022 into 10 to the power 23 multiplied by 7 divided by 14 into 10 minus 3. So that would be, so this much 7 milligram of 14C will contain, 14C will contain this much number of neutrons. Got it? Now you have to calculate the mass of each neutron. The mass of each neutron is given as this much. So what will be the mass of this much neutron? Mass of neutron in 7 milligram of 14C. So that would be 1.675 into 10 to the power minus 27 kg, and it will be multiplied by this much. So it looks lengthy, but if you are clear with the concept, then it would not create any problem. I am writing this 6.022 into 10 to the power 23 as Na. That is our Avogadro constant. Multiplied by 7 divided by 14 into 10 to the power minus 3. This much gram. Or sorry, kg. So let us see the solution. Here 1 gram is containing 14 gram. So 14 gram will 1 gram of carbon atom is containing 1 mole of carbon atom. So this is wrongly written. Okay, so sorry for the mistake. This is wrongly written since 14 gram is containing the mass of 1 neutron. Okay, so I have given you the solution. You can go with that. Now here what we have to find? Here you have to find the total number and mass of proton in 34 mg of NH3. So let us do it. So we know that the total number of NH3 molecules, so its gram molecular mass. First we will calculate the gram molecular mass. Okay, now we know that in 1 gram molecular mass there is this much number of molecules. So therefore 34 will contain how much? So we will divide it by 17 and multiply it by 34. So we will get this much number of molecules is present in 34 milligram of NH3. Now we know that the atomic number of say proton, nitrogen is 7 and hydrogen is 3. So therefore the total number of proton in one NH3 molecule will be 10. Now number of proton in this much molecules will be multiplied by 10. So that would give us this much. Now we know that mass of proton, one proton is 1.67 into 10 to the power minus 27. So therefore mass of 1.204422 in 10 to the power 22 will be multiplied by mass of 1. That would give us the mass of this much proton. So we are again and again using this unitary method here. So you can see very clearly. So if I go through it again. So first what we have done? First we have calculated the number of molecules which is present in 34 milligram of ammonia. And how we have done it? So for that we know that in 1 gram molecular mass, that is in if we calculate the gram molecular mass of ammonia, so in that much gram molecular mass we have n number of NH3 molecules. Okay, now we have calculated for 34 grams. Clear? Now in one NH3 we have 10. So for 34 grams we will multiply the number of molecules by 10. So we have got the number of protons. Now the mass of one proton is given. So the mass of this much number of proton will be mass of one proton multiplied by this much number of proton. Clear? Next, how many neutrons and protons are there in the following nuclei? We have to calculate the number of neutrons and protons. So let us do it. So it is very easy to do it. So for that you have to know the formula, which is given as number of neutron is equal to atomic mass minus atomic number. So here the number of neutrons will be, so I am writing it with, say, number of neutrons, Nn, for which carbon. So that would be 13 minus 6, 7. That is the number of neutrons, and number of protons will be your atomic number, that is 6. Next, if we calculate it for, say, 6 oxygen, then what would be the answer? So number of neutrons will be again mass number minus atomic number, that is 8. And number of protons will be your atomic number itself, that is 8. Clear? Now next, for Mg, 24 Mg. Let me write it with a different pen. Okay. Yeah. 24 Mg by 12. So therefore number of neutron is equals to 24 minus 12, that is 12. And number of proton is equals to your mass number. Sorry, atomic number. Clear? Next, let us calculate it for iron. So 56, 26. So number of neutrons is equals to 56 minus 26. That would give us 30. And number of protons is equals to 26. Next, for strontium, number of neutron is equals to 88 minus 38. That would give us 50. Number of proton is equals to 38. So the same thing is done here. So the mass number is 13, atomic number is 6. So that would be the number of proton. Total number of neutron will be 13 minus 6, 7. Again, mass number is 16. So atomic number is number of protons that will be equals to number of protons, and number of neutrons will be mass number minus atomic number, that is 8. Similarly, for magnesium, we have mass number as 24. So number of proton will be 12, and number of neutron will be 24 minus 12, that is 12. For iron, the mass number is 56. So the atomic number will be the same, the number of proton, which is given here 26, and the number of neutrons will be mass number minus atomic number, that is 30. For those who do not know what is this notation or have missed this part, so let me make it clear. So the way we write in this way, so if you just try to compare it with the general way of, say, defining a given atom, then it is written in this way. So here we have the mass number, and here is the atomic number, and this is the symbol of the element. So if you just compare it with this, then you will get your atomic number and mass number. And the number of neutron is nothing but mass number minus atomic number, and number of proton is the atomic number. Clear? Next is strontium. Again 88 minus 3850, and number of proton is just equals to the mass number, that is 38. Next, write the complete symbol for the atom with the atomic number Z and atomic mass A. So as I have told you right now, so we will do it in the same way. So atomic mass is 35, so it will be 35 here and 17. Now if you know about this element, then this is chlorine. Okay, 35 and 17. Here we have say 92 and 233. So this is for uranium, I think. To 233 and 92. Next is 4 and 9. So if you write it, 4, atomic number 4, hydrogen, helium, lithium, beryllium. Hydrogen, helium, lithium, beryllium, that is 4. It is for beryllium. So it will be beryllium 4 and 9. Got it? So same thing is written here. We have chlorine 35, 17, uranium 233 and 92, and beryllium 9 and 4. Next, a yellow light is emitted from a sodium lamp that has a wavelength of 580 nanometer. So wavelength is given 580 nanometer. We have to calculate the frequency. So for any given electromagnetic radiation, until the speed is not mentioned, we take the speed as the speed of light, that is 3 into 10 to the power 8 meter per second. Clear? So this will be your C. Now what is the relation between lambda and nu? So nu is equals to C lambda. Okay. So we have to calculate the nu. So that will be equals to 3 into 10 to the power 8. Now if you can convert this thing into meter, so 1 nanometer is equals to 10 to the power minus 9 meter. So in 580 nanometer, it will be 580 into 10 to the power minus 9 meter. So that would give us finally 580 into 10 to the power minus 9 meter. Clear? So when you multiply it, that will be 8 3 is 24 and 3 5 is 15, 16, 17, and 10 to the power 9, 0, and this will be removed. That would give us the value of nu as this much second inverse. Clear? Now if again you have to give the value of lambda bar, sorry, nu bar, that is wave number, and wave number is nothing but 1 by lambda. Okay, so lambda value is 580. So if you write in terms of SI unit, that is 580 to 10 to the power minus 9 meter. So nu bar is equals to 1 by 580 into 10 to the power minus 9. That would be meter inverse. Clear? So nu is equals to C, lambda is equals to C by nu is equals to C by lambda. C is equals to nu lambda. Okay, yeah, clear? So therefore, we have to do it in this way. Sorry, I have done the process wrong. I have taken the wrong formula here. So if you see here, I have written is C is equals to nu lambda. I have written the formula wrongly. C is equals to nu lambda. Okay, yeah. So that would give us by. Okay, sorry for the mistake. Finally, the answer will be 5.17 into 10 to the power 14 second inverse. And for lambda, the thing is the same. It is 1 by 580 into 10 to the power 9 minus 9. Next, we have to calculate the energy of the proton, which corresponds to light of frequency this much. So frequency is given. We know the formula of energy. E is equals to h nu. So therefore 6.6 into 10 to the power minus 34 joule second multiplied by nu, that is your 3 into 10 to the power 15 hertz. If you multiply it, you will get the value of energy in joule. Again, if you have to calculate for this wavelength, then E is equals to hc by lambda. Now we know again the value of h, c is constant and lambda is also given. So we have to convert first of all this lambda into your SI unit. So in angstrom, it is given in angstrom, we will convert it into meter. That would give us 10 to the power minus 10 meter. Clear? So the same thing is done here. H nu. So h value is 6.626. It has taken two more decimals. No problem. In 10 to the power minus 34 joule second. You must remember the unit of h. Okay. So that would give us finally 1.988 into 10 to the power minus 18. Next question. Next, for in terms of lambda, if it is given, you have to convert this lambda into your meter. So we have multiplied here by 10 to the power minus 10, and hc, that is your Planck's constant, multiplied by speed of light, that would give us the value of energy, that is 3.98 into 10 to the power minus 15 joule. Calculate the wavelength, frequency and wave number of a light wave whose period is 2.0 into 10 to the power minus 8 second. So for those who don't know, so period is nothing but the time taken to complete one cycle. Okay, and 1 by t is your frequency, that is the number of cycle per second. So first you will calculate frequency, that would be 1 by 2 into 10 to the power minus 10. That would give us 5 into 10 to the power 9 second inverse. Okay, now if I talk about the wavelength lambda, then c is equals to nu lambda. Lambda is equals to c by nu, and you know 1 by nu is given, that is t value is given, so that will be c multiplied by time period. So 3 into 10 to the power 8, your speed of light, into 2 into 10 to the power minus 10. So 3 to the 6 into 10 to the power minus 2. Now about wave number. So wave number will be, nu bar will be 1 by lambda, or 1 by 6 into 10 to the power minus 2, that is 100 by 6. So let us see the solution. So frequency is equals to 1 by period, that is 5 into 10 to the power 9 per second. Now wavelength we will calculate, lambda is equals to c by nu. So c by nu. Now for wave number we have taken 1 by lambda. So we got this much. Clear? Next, what is the number of photons with a wavelength of 4 picometer that provides 1 joule of energy? So this question is very good. So it has been asked that what number of proton you will take such that the total energy will be equals to 1 joule, and your wavelength is given. So first what we will try to calculate, we will calculate the energy related with 1 proton. So it is given by E is equals to h nu, we knew the formula, but here nu is not given but lambda is given. So the relation between nu and lambda is c by lambda. Nu is equals to c by lambda. Value of c is h is 6.626 into 10 to the power minus 34. C is constant, that is 3 into 10 to the power 8. Lambda is given picometer, so we will convert it into meter, that is 10 to the power minus 12. Once you will solve it, we'll get the value of 1 proton. So in one proton will contain this much energy. So it has been solved here also. So we will calculated it for 1 proton, that would give us this much energy, of this much joule of energy. Now 1 proton contains this much joule of energy, so 1 joule will contain 1 by your given value, that would give us the total number of proton. Next, a photon of wavelength 4 into 10 to the power minus 7 strikes on a metal surface. The work function of metal being 2.13 electron volt. So this is the value of work function in terms of electron volt. Okay, his wavelength is given, the photon wavelength is given. We have to calculate the energy of photon. Energy of photon in electron volt. So first what we will try to find, we will try to find the energy of photon in terms of electron volt. How we will find it? So we are given with the lambda, that is 4 into 10 to the power minus 7 meter. So first we will calculate energy, that will be h c by lambda. 6.626 into 10 to the power minus 34 multiplied by 3 into 10 to the power 8 divided by 4 into 10 to the power minus 7. So when you will calculate it, how much you will get? So it will give us 10 to the power minus 4 if you remove it. So 4 1 is 4, 4 6 is 24, again 2 remain, 4 5 is 20, 4 6 is 24, 2 remain, 4 5 is 20. So this much multiplied by 3 and 4 and 8, how much? 13. 8 and 4, 12. 12 minus 34, that would give us 34 minus 12. 4 2 2, 3 1 2. Got it? So this much is the energy related. Now how you will calculate? This is in joule. If you want to calculate it in electron volt, you will simply multiply this with 1.6 into 10 to the power minus 19 electron volt by joule. This joule and joule will be cancelled out and you will get an energy in electron volt. Now you will further subtract this value with this much and you will get the energy of photon in electron volt. So what we have done, and again we will see the solution. We have calculated the energy with this formula. So that will be the energy of one photon. Now we have converted this into electron volt. So for that we have multiplied it with 1.6 into 10 to the power minus 19. So we divided it with 1.6 into 10 to the power minus 19. Why we have divided it? Because 1 joule is equals to 1.6 into 10 to the power minus 19. Clear? Electron volt. Okay, got it? 1 electron volt is equals to this much joule. Now 1 joule is equals to this much by that much. Okay, clear? So that would give us finally, this relation is written wrong. 1 joule is equals to this much. Okay, I'm getting confused here. So you have to convert this value, this joule value, to electron volt. Okay. So here we will write it as 1.6 into 10 to the power minus 19 joule is equals to 1 electron volt. Yes, it's clear. So this is written wrong here. Sorry for this mistake. It will not be divided, it will be multiplied. Okay, it will be multiplied. You have to multiply this one. As I have told you, we have to multiply it and then we will subtract it. Clear? Next. Yeah, we have to divide it only. We have to divide it. We have to divide it by 1.6 into 10 to the power minus 19. Then we will subtract it and get the kinetic energy. Next, we have to calculate the velocity of that electron. So we have already calculated energy. Here we have calculated energy in electron volt, 0.97 electron volt. And you have to find the value of velocity. So we know that energy is equals to half mv square kinetic energy. So what we will do finally? We will just take this v here and put all the next values here. Okay, so that would give us multiplied by 2 divided by mass of electron. So mass of electron, we know it, 9.1 into 10 to the power minus 31. We have taken the joule value rather than your electron volt value. So we will get the final velocity as 5.844 into 10 to the power 5. Clear? Next, electromagnetic radiation of wavelength 242 nanometer is just sufficient to ionize the sodium atom. So what does it mean? So this means that this is the energy required. This is the amount of energy required to remove one electron from the sodium atom. Calculate the ionization of energy of sodium in kilojoule per mole. Okay, we have to calculate it in kilojoule per mole. So it is given for one atom of sodium. So first we will calculate the energy. It is given wavelength. So first we will calculate the energy. That would be h c by lambda. We know the value of h 6.6 into 10 to the power minus 34. Value of c 3 into 10 to the power 8. And your lambda 242 into 10 to the power minus 9 meter. So that would be the energy required to remove one electron from one sodium atom. Okay. So for mole, what we will do? That means for 6.022 10 to the power 23, we'll simply multiply it with 6.022 into 10 to the power 23 to get the energy required for pulling for pulling electrons from 1 mole of sodium atom. So we have done the same thing. We have multiplied. First we have calculated the energy and we have multiplied it with Na. So for that we got 494 kilojoule per mole. Next, a 25 watt bulb emits monochromatic light of wavelength 0.57 micrometer. Okay. So this is energy. This is the value of 25 watt. So watt is nothing but it is work energy rated per second. Okay. And this is wavelength. This is wavelength of that one light. So calculate the rate of emission of quanta per second. Calculate the rate of emission of quanta per second. That how many quanta of wavelength, how many quanta of wavelength, not how many quanta of protons is emitted per second from this light. We have to calculate this much. Okay. So for that we have to calculate the number of protons first of all. So this is the watt that is given. That is the number of released per second. Number of protons released per second. And this is the energy. This is the wavelength of that. So how will calculate it? So 25 joule of energy is released per second. Of energy is released per second from the bulb. This 25 watt means this statement is the meaning of 25 watt from the bulb. Okay. So in this much joule of energy, how many numbers of protons are there? How will calculate? So for that you have to calculate the energy of one proton and divide it by this much. So energy of one proton will be h c by lambda. That would be 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 0.57 into 10 to the power minus micro. It is given in micro. That would be how much? Minus 6 meter. Okay. Now we will just take it as energy of one proton will be number of protons will be how much? This energy divided by this 25 joule divided by energy. That would be the number of protons. Okay. Now quanta we will divide it by h. Okay, we will divide by h. So let us see this. So first we have calculated the energy related to this. Thus the rate of emission of quanta per second is nothing but this energy, and that is divided by 25. Okay, clear? So this was for today's class. We have seen 11 questions from NCERT. We will see the next in the next class. Okay, thank you.